Hey there, class. Mrs. Matheson here. We're going to be in Unit 6, Notes 2, and we're going to be covering geometric mean. Our learning target today says use geometric means to solve parts of right triangle and to find altitude to its hypotenuse. All right, so first we need to talk about geometric mean. Geometric mean actually comes from a proportion, which we've done proportions. We've talked about a proportion used to compare two equal ratios. So here we have a over x equals x over b. We actually can label these. We have what's called an extreme and a mean. And our x is going to be the mean, and our a and our b are going to be the extremes. Now, if I asked you guys to solve this for x, what should your thought be? Yeah, it should be cross multiply. All right, so we get x times x, which gives us x squared, and then a times b. Well, if I wanted just x, not x squared, we'd have to get rid of that square. And the opposite of that is square root. So those will cancel, and I'm left with x equals the square root of a times b. When the means of a proportion are the same number, that number is called the geometric mean of the extremes. All right, and we're going to use this idea and we're going to take it and put it with triangles. So just this little box here you need to keep in mind for a little bit. The mean is going to be the altitude of the triangle. If you're not sure what that is, we'll cover that in a minute. And the mean is this x, remember? And so we're going to use the altitude used twice. All right. So we're just going to do geometric mean for some numbers. So find the geometric mean between 8 and 10. So let's just call 8 our A and 10 our B. So we could put them into this proportion here and solve for x. So we get x squared equals 8 times 10, which gives us 80. So x is the square root of 80. Or, again, let's just round to one decimal place, 8.9. We could do this in a more simpler fashion and just jump right to this portion right here. We have 9 and 4 in this next problem, so A and B. So x is the square root of A times B. 9 times 4 gives us 36, and the square root of 36 is 6. We'd get the exact same answer if we set it up into our proportion to begin with. So why don't we just jump right to this part here and skip the beginning part. All right, so now let's get into talking about those altitudes because the bulk of our notes that we want to cover are going to be based off of this altitude and these triangles. An altitude is a segment drawn from the vertex of a triangle perpendicular to the line opposite. So the vertex that we're going to use is actually going to be our 90-degree angle. Our altitudes are always going to be drawn from our 90-degree angle. So it's going to be perpendicular. And so this makes a 90-degree angle there. Those are the altitudes we're going to be dealing with. That's also going to be our height for our triangle when we talk about that. So let's use that idea. Using the geometric mean with right triangles. If the altitude is drawn to the hypotenuse of the right triangle, so we're going to draw one in for our picture here, then it forms two right triangles that are similar to the original. So we see our original triangle here with our big A, B, oops, that didn't mean to move, with our big A to B to C. That's our original triangle. I'm just going to jot that out here. A, C, B. Now when we put in our hypotenuse, or I mean our altitude to our hypotenuse, we have given ourselves a new point here. We're going to call that point D. Now we've created two more triangles. Because this is perpendicular, these are both right angles. We have created this triangle here. We'll call this our medium-sized triangle. And I'm going to flip my medium-sized triangle so that it is going to be in the same direction as my large triangle I have here. So I'm going to do my medium-sized triangle here. Okay, so now we have our A, D, and B as going to be, or I mean, D, B, and C as our points. So C and B now become our hypotenuse because it's across from the 90-degree angle. So I have C and B here and D on top. We'll move those out of the way. No, you triangles, stay there. We're going to move those out of the way. Then we have a small triangle formed right here. And I'm going to draw that out here. Again, across from our 90-degree angle has created our hypotenuse, which is now C and A. And that leaves D to be our one with our 90-degree angle. So we have some similarity statements we can state here now. If CD is the altitude to the hypotenuse of AB, we can say that triangle ACB, that's our large one, is going to be similar to, let's look at our medium one here. We have CDB. Okay, we also have our large triangle. That's going to be similar to our small triangle. And so we're going to match up and say A and D and C. Then we can compare our medium-sized triangle and our small triangle. Our medium-sized triangle ADC and our small one is CDB. We have three similarity statements that we've created here. And remember, with similar triangles, we know that the sides are proportional and that the angles are congruent. The sides being proportional is what is going to pull in that geometric mean that we've talked about. We're going to use that here. Geometric mean, now we're going to talk about is altitude theorem. The altitude drawn to the hypotenuse of a right triangle separates the hypotenuse into two segments. So if we draw in our altitude here, and we're going to call that point D again, now it's created two additional segments. We have segment X here, which is from A to D, and we have DB, which we're going to call as Y. So we have two smaller triangles that are similar. The length of the altitude is the geometric mean between the lengths of these two segments. So I'm going to call that H for height. So we can say that geometric mean, that H, is going to appear twice, just like it did in the beginning problems that we talked about. Now I can say X over H is proportional to H over Y. And really, if I draw out my two smaller triangles and say X, H, and B, that's the small one on the left side, and I draw out my medium-sized one, which was on the right side, my H this time is going to be here, and my Y is going to be here, and that A is my hypotenuse. We can say that X is my short leg over my long leg of H. H in my other triangle is now my short leg. And Y has become my long leg because I'm looking at a different triangle. So we have short legs over long legs. And we see that H is the long leg in one and the short leg in the other. Now, we can say that we can solve this by cross multiplying. H times H gives us H squared equals X times Y. So if we just want H, H is the square root of X, Y. All right, so we're going to keep that in mind to when we get to the back of the worksheet or the note sheet. We're going to do these, we're going to do these next problems, 3, 4, and 5 together in class. We're going to talk about drawing out the three triangles, just like we did here. And we're going to use the similarity statements to help us put into some proportions, long legs and short legs. All right, so be ready for us to tackle 3, 4, and 5 when you return back to class. We'll see you then.